Good morning, students. Today, one important topic in chapter 2 we will continue. Potential energy of system of charges. See, we have total two theory for potential energy of system of charges. First, without external field, and second theory will be with external field. See, what is without external field? See, you are given system of three charges, Q1, Q2 and Q3, having position vectors r1, r2 and r3. Your question is, find what is potential energy of this system. External field is 0 means you have only these three charges. External field is not present. Okay, so how to find this potential energy? Potential energy means what? We know that to bring a charge from one point to another point, we have to do some work, and that work is stored as potential energy. We know that at infinite distance, potential energy is 0. So, what we are thinking here? Here, initially we are assuming that these three charges Q1, Q2 and Q3, they are at infinite distance. This Q1, this Q2 and this Q3, they are at infinite distance, Q1, Q2 and Q3. All three charges are at infinite distance. So, what is left in this region? Nothing. There are no charges, no external field in this region at point A, at point B and at point C. Now, what is method? See, first of all, we will bring Q1 charge from infinite distance to point A. Find work, that work is stored as energy. Then we will bring charge Q2 from infinite distance to point B. Find work. Then we will find work to bring charge Q3 from infinite to point C. So what is method? First of all, you have to assume that all these three charges are at infinite distance. In this region, there are no charges, no external field. One by one, bring charges to respective points. Find work done. That total work done is stored as potential energy. Okay, see, we consider three charges Q1, Q2 and Q3 initially at infinite and determine the work done to bring the charges to given locations. This work done is stored as potential energy. First, we will bring charge Q1 from infinite distance to point A. Okay, charge Q1 is brought from infinite distance to point A. Now, what is potential at point A? Say, in this region, there are no charges. There is no external field. Then at point A, potential is 0. Potential at point A, VA is equal to 0. Then what is work done to bring Q1 charge from infinite to point A? We have one equation of work done. W is equal to QV. W is equal to QV. Then W1 is equal to Q1 VA. We have to bring Q1 charge from infinite distance to point A. From infinite distance to point A. Now, actual equation is W is equal to Q delta V is equal to Q VA minus V infinite. But at infinite distance, potential is 0. At infinite distance, potential is 0. So, we can write W1 is equal to Q1 VA. VA is equal to 0 is equal to 0. It means here there is no external field. So, to bring Q1 charge from infinite distance to point A, no work is done. Work done is equal to 0. Chap. Now, Q1 charge is brought to this point A. Now, we have to bring Q2 charge from infinite distance to point B. To point B. Now, see, in this region, there is one charge Q1, and due to this Q1 charge, there is some potential at point B. So, when you bring charge Q2 is brought from infinite to point B, at point B you have some potential, and that potential is due to Q1. Potential at point B is due to Q1. What is equation? VB, potential at point B is equal to K Q1 upon R12, where R12 is distance between 1 and 2. Okay, so at point B, potential is due to this Q1 charge. VB is equal to K Q1 upon R12. So now what is work done to bring Q2 charge from infinity to point B? W2 is equal to Q2 VB. We have to bring Q2 charge at point B. Q2 charge at point B. So W2 is equal to Q2 VB is equal to Q2. What is VB? K Q1 upon R12. So is equal to K Q1 Q2 upon R12. Clear? Why we have used the K? Because we are assuming that these all charges are placed in L. Now if we have system of only two charges, Q1 and Q2, chalo, Q3 is absent. If we have system of only two charges, then what is work done to bring Q1 charge? W1. What is work done to bring Q2 charge at point B? W2. Then for system of two charges, Q1 and Q2, potential energy of system U is equal to total work done. W1 plus W2 is equal to 0 plus KQ1 Q2 upon R12 is equal to KQ1 Q2 upon R12. So if you are asked the potential energy of only two charges Q1 and Q2, then your theory is over. But here we are given three charges. See, we brought Q1 charge from infinity to point A, Q2 charge from infinity to point B. Now we have to bring Q3 charge from infinity to point C. Okay, we bring Q3 charge from infinity to point C. Now see, from figure it is clear. Now at point C, is there any potential? Yes, due to Q1 and Q2. Due to Q1 and Q2. So at point C, potential is due to Q1 and Q2. How to write? See, potential at point C is due to Q1 and Q2. So VC is equal to KQ1 upon R13 plus KQ2 upon R23. And if work done to bring Q3 charge from infinity to C is W3, then is equal to Q3 VC. Bring a Q3 charge from infinity to point C. Okay, VC, here it is. You have to multiply Q3 to each term. Okay, so K Q1 Q3 upon R13 plus K Q2 Q3 upon R23. Okay, to see one by one, we brought Q1, Q2 and Q3 charges from infinity to point A, to point B and point C respectively. W1 work, W2 work and W3 work. So what is potential energy of system of these three charges? W is equal to W1 plus W2 plus W3. U is equal to K Q1 Q2 upon R12 plus K Q2 Q3 upon R23 plus K Q1 Q3 upon R13. So it is potential energy of system of charges. Now say, how to make a conclusion from this equation? We have already studied one topic, gravitational potential energy in 11th, in gravitation chapter. Remember that square order sum. Okay, what is gravitational potential energy? Its equation minus Gm1 m2 upon r, and you have to identify number of pairs. Similarly, here you have to identify number of pairs. You are given three charges. So between three charges, how many pairs are possible? Yes, three. Between 1 and 2, 2 and 3, and 1 and 3. So for each pair, what is equation of potential energy? K Q1 Q2 upon R12. Potential energy for 1 and 2. K Q2 Q3 upon R23 for 2 and 3. And it is for 1 and 3. If you are given two charges only, then you can use this equation K Q1 Q2 upon R12. Clear? If you have four charges, then to find total potential energy, you have to adopt similar method. Pause your video, write down from board, make notes and send notes on my WhatsApp number. Our next theory will be potential energy of system of charges in external field. In external field. Clear? One question based on potential energy of system of charges. See, you are given a system where two protons are at a distance 1.5 angstrom. Electron is at a distance 1 angstrom from each proton. Okay, so total you are given three charges. 2 proton and 1 electron, and you have to find potential energy of system. So first of all, for these three charges, identify numbers of pair. Yes, first pair between proton and proton, second pair between proton and electron, and third pair is between this proton and electron. See, three pairs between proton, proton, proton and electron, proton and electron. Okay. What is distance between these two protons? 1.5 angstrom. Between proton and electron, 1 angstrom. Between proton and electron, 1 angstrom. Okay. So what is potential energy of system? U is equal to, for this pair, K. What is charge on proton? E. Charge on proton? E. Distance between them, R1. Clear? Okay. For second pair, K. Charge on proton, E. Charge on electron, minus E. Charge on electron, minus E upon R. Similarly, for this third pair, K. Charge on proton, charge on electron, and distance is R3. So U is equal to Ke square upon R1 minus Ke square upon R2 minus Ke square upon R3. Okay, you know what is value of K, what is value of E, and yes, convert this angstrom in meter. We know that 1 angstrom is equal to 10 raised to minus 10 meter. So it is your homework. You have to calculate this sum and send notes on my WhatsApp number.